My name is Elad Simantov. My major is electrical engineering. I am the team leader of this project. My positions in this team will be RF circuit designer and antenna designer.
Hello, my name is Alex Perdomo. I'm an electrical engineer, and I will be in charge of modulation and demodulation of the circuit board. I will also be the auxiliary personnel for the whole team.
Hi, my name is Gilbert Coriolan. I'm an electrical and computer engineer, and I'll be responsible for debugging the software and testing the hardware.
Hi, my name is Monica Valiente. My major is computer engineering, and I'll be taking care of programming the user interface.
My name is Fidel Rodriguez, and my major is computer engineering, and I'll be in charge of programming the microcontroller.
I'll be presenting the rectifier/regulator board for our wireless power transfer project. This board will take the AC voltage from the pair of antennas and convert it into DC voltage. This is the power amplifier that we're using. And this is our function generator, which generates the carrier wave. So if you hear on the voltmeter, you can see that we're getting a pretty stable 4.6 volts. Another component of our project is the RFID modulation, also known as backscattering modulation. This can be achieved by using a BJT at the receiving end of the antenna, which open and short circuits the antenna based upon the square wave that's being fed into it. This is our function generator, which generates the carrier wave. And this is an additional function generator which generates the square wave, also known as a binary wave. The oscilloscope will display the output from the envelope detector, which is at the transmitting end. So therefore, the binary wave is being reflected back to the power source, as can be seen here on the oscilloscope. Another potential component of our project is the receiver board, which has to demodulate a signal, an incoming signal, if we're going to be implementing it that way. So here we have two function generators. One is for the receiver and one is for the transmitter. This is the transmitter circuit, and this is the receiving circuit. They're connected together through the SCMR antennas. And over here, this is generating a square wave, or a binary wave, that will be demodulated by this receiver board, also known as BPSK modulation. So on the oscilloscope, you can see that we can clearly discern the bits, whether they're zeros or ones. So it's pretty successful. We just have to implement a filter that will correctly capture this. These are our wideband SCMR antennas. We connected them to the network analyzer after calibration. And over here we can see that the reflection coefficient is very low, about negative 25 dB, while our efficiency for these antennas is about 61%. So they make pretty good antennas. We also have a narrowband model, which I will show you as well, and those have a greater efficiency. These are our narrowband SCMR antennas. They don't have great bandwidth, but they have an excellent reflection coefficient of about negative 30 decibels, and they operate at around 63.2 megahertz. So these are great for just transmitting power, but if we're going to be using data at the same time, so we might have to use the wideband SCMR antennas. And they're also about 88% efficient, so they're excellent.